Hi, my name is Widi Aditya, and today I'll be presenting my report on the case study of green IT technology of PT ABM Investama Tbk. This presentation explores how the information technology function of the company has an opportunity to be a strategic driver of sustainability by reducing its environmental impact while creating business value. And here is the outline for today's presentation. I will begin with the background and the urgency of Green ID. Then I will define key concepts, discuss IBM Investama's IT challenges, and introduce the theoretical foundation, which is this dynamic capabilities framework. And the next one, I will explain my proposed sustainable IT dynamic capabilities model, or SIDC, followed by its implementation roadmap, performance metric, expected benefits, and the final recommendations. The background of this work comes from the fact that globally, the ICT sector is projected to account for around 7% of total greenhouse gas emissions by 2030, as reported by Gomez in 2025. At the same time, environmental regulations are tightening, and stakeholders, including investors, employees, and customers, are demanding measurable action. However, sustainability in the IT context is beyond regulatory issue. It also creates tangible business value through cost savings, climate-related risk reduction, and competitive advantage. To frame this discussion, I present the two key concepts. First is the Green ID. Green ID is defined as the practice of designing, using, and disposing of ID systems efficiently and responsibly. The second one is the triple bottom line framework. It is about balancing environmental responsibility, or the planet aspect, social equity, or the people aspect, and economic viability, or the profit aspect. By combining these two concepts, it is evident that IT should also consider how it is consumed and delivered. It is related to the economical value as the profit aspect, responsible use of energy and electronic waste management for the planet aspect, and last but not least is the people aspect, whereas each individual must have an awareness of how an IT product is used ethically. For instance, raising awareness of how to select an energy-efficient IT device, or for the company to partnering with the local electronic waste management. By doing so, the Green ID concept is not just about environmentally responsible design, but it also creates digital inclusivity to its users, from the earliest product selection, responsible use during its lifetime, and proper end-of-life disposal. According to the company's public report and available information found in the company's website, I identified 4 IT sustainability challenges in PT ABM Investama Tbk. The first one is the high energy consumption. The company operates data centers 24/7, which is contributing to the Scope 2 emissions. And the second one is the inefficient asset life cycle, where we found the lack of circular economy principles in procurement and disposal of IT assets. The third one is the server sprawl, which is low virtualization rates. This is wasting resources as well. And the last one is the IT governance. We don't find any particular IT task force to govern the whole IT operation. To address the challenge faced by the company, I adopted this dynamic capabilities framework because it focuses on how organizations build and renew capabilities in fast-changing environment. The framework has 3 micro-foundations. The first one is sensing, which is to identify and assessing opportunities or threats. The second one is sizing, which is mobilizing resources to capture value. And the third one is transforming, which is continuous renewal of assets and capabilities. This theory considered fit with the company's aspiration of sustainability, which demands agility, innovation, and long-term capacity building. Based on this framework, I further developed the Sustainable IT Dynamic Capabilities Model, or SIDC model. The SIDC model adapts these dynamic capabilities specifically for IT sustainability. It follows a continuous cycle, which is sensing, sizing, transforming, and back to sensing, ensuring ongoing improvement. This represents a strategic shift from isolated, one-time sustainability projects to an embedded, organization-wide capability that integrates technology, processes, and people. This table summarizes how each capability translates into action. For instance, sensing involves sustainability assessment and data analytics, while sizing drives execution through virtualization, policy adoption, and efficient IT design, and transforming focuses on cultural change, embedding sustainability in training, performance management system, and strategy updates. Together, these elements create a resilient, adaptive IT ecosystem. As we can see, the solution mapping table here connects the company's IT problem with SIDC-based solution. For example, like in the high energy consumption, by adopting sizing from the SIDC model, we can propose a better power management that is supported by a particular software. For the inefficient IT asset lifecycle, we can drive a circular IT procurement and disposal policy. For the lack of cohesive strategy, we can create a permanent green IT governance council. And for the server sprawl and underutilization, we can propose to execute server virtualization. For the implementation strategy, the first step is to establish a robust green IT governance. The company should create a team consist of people from IT, finance, operation, and corporate sustainability. This task force will have the official mandate to carry out the sensing of the SIDC model, as well as for ongoing monitoring, setting green IT policies, and implementing a sustainability strategy for IT. The main task of this particular task force is to conduct an audit to examine current IT practices, explore what are the risks and opportunities, as well as to set the baseline for further sustainable development. This phase is also crucial to set the basis of performance metric, which will be adopted by the company at the later stage. It is also important for the task force team to prepare a budget allocation as part of the company's transformation stage from sensing to sizing. After that, by utilizing SIDC model as a strategic guideline, the company can officially adopt sustainable IT dynamic capabilities mode. For instance, by providing a formal appointment or an approval of the project charter from the senior management. The next step is to embedding sustainability metrics into IT performance management. The transforming stage cannot be achieved without sustainability being embedded in the DNA of the organization. Moreover, it's also noted that this phase should start to engaging people, particularly employees, in order to raise the awareness of the importance of the green IT to support the sustainability of the company itself. This might imply the analysis of consequences of green IT activities on employees' well-being. This foundation also will become the basis of future innovation, where the company is willing to exercise and exploring possibilities of green IT adoption that goes beyond compliance, such as the use of Internet of Things or IoT for a predictive maintenance, AI-based corporate data management and analytics, also opportunities to partner with the local suppliers or vendors with specifically addressing IT challenges. For example, to partner with e-waste recyclers who are certified for safe and ethical decommissioning of all end-of-life IT kit. which all of these initiatives will turn a business as usual into tangible corporate social responsibility initiative. The implementation roadmap is designed as a 4-year implementation. In year 1, IBM initiated the process with the forming a Green IT Governance Council, conducting a sustainability baseline audit, and launching a virtualization pilot. During years 2 and 3, the focus shifts to scaling, expanding virtualization to 40 to 50%, introducing circular procurement, and deploying softwares. Finally, in year 4 and beyond, sustainability becomes business as usual, with green KPIs integrated into performance management and IT strategies designed as green by design. To measure the progress, the management has to incorporate green IT relevant performance metrics and KPIs. As we can see, the table has 3 separate metrics. They are environmental, economic, and operational metrics, whereas each metric has interlinkage. The first one, in the environmental metrics of power usage effectiveness, it correlates with energy cost saving and utilization of virtual servers. Second, the electronic waste metric aligned to the amount of return of investment of the project, and this will support the green procurement practice as well. Third, the KPI of carbon footprint reduction in line with the IT device lifecycle cost reduction and employee awareness of the initiatives. Below the table, we also can see the tangible key performance indicators that sets the success rate of the project. To conclude, the Sustainable IT Dynamic Capabilities Model, or SIDC model, offers a rigorous, adaptive, and strategic pathway for sustainable IT transformation. It directly addresses the company's operational inefficiencies while delivering measurable value across the triple bottom line, which are environmental or planet, economic or profit, and social or people. It also positions IT function as strategic enabler of corporate sustainability. And lastly, 4-year implementation ensures sustainable and seamless transformation. Thank you.